Hi, this is Eric White. This is the next screencast in this ongoing series of screencasts on recursive pure functional transformations. Congratulations if you have made it through. This is screencast number 21. This screencast is on grouping. Grouping, while not hard in and of itself, is something you have to understand in order to do recursive pure functional transformations of Open XML. There are basically two varieties of grouping. The first is grouping all like items, and the second is grouping adjacent like items. So let's go talk about both of these types of grouping and why we use them and when we use them. Here we have a little data set. This data set has a set of names of project managers and a set of names of the projects that each of these project managers manage. We might want to take this data set and generate an Open XML document from this data set. One of the requirements for this report that we're going to generate is that all of the projects for each project manager should be listed just for that particular person. We don't want to see them interspersed as they are in the data set. So therefore, we need to group them. I'm going to create a new collection called Grouped Projects. And there we have it. So now we can do a few little things to make sure that we did everything properly. Let's first of all see how many groups we have. And we have 3 groups. That's what we expected. The results of this grouping operation, this group by operator, is a collection of collections. So we can iterate through this collection of collections and look at each item in each of the relevant collections. First, we'll print out the key. And because item itself is a collection, we can iterate through item. And if we run it, we see that Eric has 3 projects: Power Tools, Open XML SDK for JavaScript, and Screencast Procedures. Brant has 2 projects, and Lisa has 1 project. Now we want to go through a process of generating an Open XML document. I'm going to dramatically simplify the Open XML markup that we're generating. I'm not going to generate real Open XML markup. I'm more interested in explaining the concepts around grouping rather than combining that with all of the details that you need to know to generate valid Open XML markup. So I'm going to simplify the resulting XML by quite a bit. I need to have system.xml.link in place. So now I'll new up a new document. And in this document, I'm going to take grouped projects and I am going to project into content that goes into this document. Let me show you what I mean by that. I take grouped projects and I'll dot into select. Now, when I take something that is grouped and I project it into a selection or some other thing, I typically use the variable g for my lambda expression. It just makes things easier. And I often will, just for simplicity's sake, project into a statement lambda. And the first thing that we need for each project manager is we need a heading paragraph to give their name. So we need a new X element, and it's a P element, and we need an attribute indicating the style. and we need some content for this paragraph. So we'll put in a new X element with a run and a new X element with a text node, and I'll put in project manager plus g.key. This is the heading, so I'll do something like that. Heading is equal to that. So now I've created a paragraph for the heading, and now I need to create a paragraph for each of their projects. So, and G is the collection of projects, so I take G and I select, because I'm projecting from there. And so these are all the items within G, or all the projects within G. So for instance, for Eric, we're going to have Power Tools and Open XML SDK for JavaScript and screencast procedures. That's going to be each one of these items in the group. So I might call this group children. That's a common name of the Lambda variable that I would use. I also sometimes call it GI for grouped item, or you can make it be whatever you want. It doesn't really matter. Again, I'll make it a statement lambda just for ease of coding. Again, I need a P for a paragraph, and I need an attribute of style, and this is just normal. And then I need a run element. And the project name is going to be this GC. And so this will result in a collection of X elements. So we have heading up here, which is a single X element. We have projects here, which is a collection of X elements. And we want a blank paragraph in between each of our project managers. So I have to, up here, I need to return this para because they're in that statement lambda, and it doesn't like that name because I already have a variable named projects. So I'll call it projects for PM, for project manager. So now I have a singleton, this heading, and I have a collection, this projects for PM, and I have another singleton, this blank line. I can just return all of these in a single collection, and the semantics of linked XML will work just fine. It'll take the heading and it'll insert that into the document element. It will take the projects for PM, it will see that that is an IEnumerable, and it will take every item in there and also insert that into the document element. And then it will take this blank line and also insert that into the document element. But we need to create a collection of all of that. So the way that you create a collection of a bunch of dissimilar things, you just declare a little teeny array right in place. And it's going to complain here because I don't have a best type for this implicitly typed array. And the reason why is I have an X element right here, an IEnumerable of X element here, and an X element right here. Well, the little trick that you do here is you just throw in an object on one of the items, and that will make the compiler happy. We've seen that same approach before because you have to do this using the C# type system. There are cases here where the C# type system isn't quite robust enough to describe this particular case where we have an item that could either be a singleton or a collection. Also, to make this consistent with my example that I'm going to show next, is I'm going to put a body element in here. And I'll have to come down here and put in another close parenthesis and reformat all of that. Let's see, I want this to be indented one more, and the indentation, the automatic formatter of C# doesn't quite get what I want here. So there I have it. I have taken my project's data, I've grouped everything by the project manager, and then I've projected a whole document that has a document element, a body element, and then a section of content for each project manager. The first part of that section of content is the heading with the project manager name, and then for every project it has a paragraph with the project name, and then finally it has a blank line between the various project managers. So let's print out this XML and take a look at it. And let's run it. Let's go up here and look at it and see what we have. So we have our document, we have our body, and then the heading 1, and we have project manager is Eric, and then we have a normal paragraph, and the project name, I actually didn't take just the project name, I took the entire anonymous type, and I didn't detupleize it. The next screencast in this series, I'm going to talk about tuples and tupleizing in the middle of a projection and removing tuples in the middle of a projection. But this is a good example of one. So I need to go fix this issue. The only thing that I have to do is right down here is I have to dot into project right there. And if I run it again, now I can see project name Power Tools, project name Open XML SDK for JavaScript, project name Screencast Procedures, and then here we can see the blank line between the various project managers. And there we can see Brant's 2 projects, and at the bottom we can see Lisa's project. So that's what grouping is all about. Grouping is about taking a collection and projecting a hierarchical data graph from there. So in other words, we take this collection that is a flat collection of data, and the results of this group by is a collection of collections that we can then further do an appropriate projection from. One small interesting tidbit is language integrated query was designed intentionally to look a lot like SQL. So that's why select is named as it is, and aggregation and grouping are named as they are. Really, these are all variants of the various MapReduce concepts. With LINQ, it's been altered to look more or less like SQL because the people in charge at Microsoft wanted to make it look as familiar as possible to as many people as possible. It is a big transition to start thinking in the pure functional style, and many people are familiar with SQL, so by making language integrated query look like SQL, it helps people to kind of feel comfortable with it as quickly as possible. But one key difference is that with SQL, you always project a rectangular result set out of any SQL query. But that's different from LINQ, where you can project a hierarchical result set out of a query. Now let's take a look at another example here. Here is a little simulated document. Again, I've simplified the markup significantly. All of these concepts apply when you are working with real OpenXML markup, of course, but in order to demonstrate these concepts, it's easier if we work with markup that's very simple. Let's say that we're in the process of transforming this document to HTML, or we might be transforming it into some form of XML to be put into a database or what have you. We want to transform this document in some fashion. And let's say that in the process of transforming this document, we want to group things together. Let's say in our HTML, we want to put a div element around every collection of normal paragraphs. So we want a div element around the first two normal paragraphs. We want a div element around the next three normal paragraphs, and we want a div around the last two normal paragraphs. Well, this is where the ordinary group by operator doesn't work for us. Because let's say that I want to group by the style. We're going to get this heading 1 paragraph in a group. We're going to get these two heading 2 paragraphs in a group, and then all of these normal paragraphs will all be clubbed together into a group. I often like to format these like this because it helps me to see the query in an easier way that I can see, okay, we're starting with the document element, I'm dotting into the body element, I'm then querying over the collection of paragraph elements, and then I'm grouping by that style attribute in each of those paragraph elements. So now let's iterate over this grouped paragraphs and see what the result looks like. And as you'll recall now, this item is a group. I'll call this G here just to make it simple. So the group child in G, and I'll put a blank line in between each group so that we can see them more easily. And when we run it, we can see exactly what I described. We have the heading 1 paragraph in its own group, the two heading 2s in their own group, and then we have all of the normal paragraphs in their own group. Well, this isn't what we wanted at all. What we wanted to do is we wanted to group adjacent paragraphs. And as part of Power Tools for Open XML, there is an extension method to group adjacent. So all we have to do is come up here, and we're just going to change this to group adjacent. And now let's run it. It gives me an error because I need the power tools in place here in order to use that. So I'll go grab those fellows. Okay, here I have copied in these two modules, this ptutil.cs and pt-openxml-util.cs. Technically, in this particular case, we only need ptutil.cs. ptutil.cs has methods that are really just relevant to functional programming. They're not really relevant to OpenXML in the large. However, these methods are very much methods that I use a lot in Power Tools and elsewhere in my development. Now I'll go to my Visual Studio project and I'll add some existing items, and I'll add them both to my project. And I also have to add a using to OpenXML Power Tools, and you can see it now found group adjacent. And if I run it, it's complaining that I don't have the OpenXML SDK in this particular project, but you know what? We don't need this module here right now, so we'll just get rid of it. And now we'll run it. And this is what we wanted. We wanted the heading 1 to be grouped all by itself, and then we wanted these two normal paragraphs to be grouped by themselves, and then the heading 2 is in a group all by itself, and then 3 normal paragraphs, and so on. So let's go through a process of generating a bit of pseudo HTML from this. So I'll get rid of all of this code to dump out the grouped information. And now I'm going to put in var HTML is equal to new X element HTML. And we need a body element. Now for every heading 1 paragraph, we need to generate an H1 element. For every heading 2 paragraph, we need to generate an H2 element. And for each one of these collections of normal paragraphs, we need to generate a div element that contains the paragraphs that go inside there. So we want to take grouped paragraphs and we're going to project from there. And we're certainly going to make this a lambda expression. It's going to be complicated enough. So first thing we want to do is, if the style is heading 1, we want to generate an H1. This G is a group of things. Then theoretically, it's possible that we could have 2 heading 1s right next to each other, in which case we really want to generate 2 H1s right next to each other. So we can take this G and we put it into a projection, in other words, into a select, and the grouped child. I'll just put it in the return right there so that we don't need to put it in a variable and then return it for something as simple as this. So there we've handled heading 1. And the code for heading 2 is going to be almost identical. And finally, we need to deal with the normal paragraphs. And with these normal paragraphs, if you recall, we want to surround each collection of normal paragraphs with a div. That was the whole reason why we were grouping adjacent here. So we're going to create a div element, and let's say that this div element has a class. And we'll call this class norm para. And now we can take this G and project that into each paragraph that goes into this div. And again, up here, if we look up here, it's going to complain because this one is returning a collection. This one is also returning a collection. We're taking that G and we're projecting through the select. But this last one is returning a singleton, which is the div that contains the collection. So once again, we can solve this by putting a cast to object on the first one. I always follow that particular approach, is just put the cast on the very first one, and that clues me into that I've got one of these projections where I'm returning both singletons and collections. That's kind of my mental clue as to what this code is doing when I come back and look at this code after years have gone by. Well, we're done, so let's print out our HTML and take a look at it. Run it. It's complaining that I don't return something if it's not one of these 3 things. So to make it simple, I'll just return null. I'll say if it's not one of these other things, we're just going to ignore it. This return null will not get executed with our particular data set, but it's kind of a defensive programming technique. If I run it, and here we can see the HTML element. Underneath that, we can see the body element, and then here we can see the H1 element. We can see our div with the class of norm para, and we can see the various paragraphs inside of that div. And here's our H2, and its div underneath that with the collection of normal paragraphs and so on. And with this code, you can see why I needed to do group adjacent, because I didn't want to group those H2s together, and I didn't want to group all of the normal paragraphs together. I wanted to group them only with their adjacent fellows. In document format programming, in these types of transforms, I have to tell you that I use group adjacent probably 10 to 1 over grouping. Group adjacent is one of those key things that you need to do when you are processing a document in document formats. It's rare that you actually need to group something. You might need to group something when you're taking a data set that is completely different, like our example that I showed to you, and projecting a document format from that. And you might need to group things together, not using group adjacent, using the ordinary grouping method if you are extracting data from a document. But when you are transforming from one document format to another, in other words, you're transforming from document-centric XML to another form of document-centric XML, regardless of whether it is a transform into another document of the same vocabulary, which would be the case if you're transforming Open XML into other valid Open XML, or if you are transforming into a different vocabulary. In this particular case, we're transforming from pseudo Open XML into pseudo HTML. Group adjacent is much more commonly used than grouping. We've shown grouping previously, but it's worthwhile just go into it in depth. I know that in this screencast series, I'm going to repeat myself here and there. To be honest, I can't remember everything that I've covered in all of the previous screencasts, and a little bit of repetition doesn't hurt anybody anyway. It will help to make all of these concepts clear. In the next screencast, I'm going to dive into the whole idea of creating tuples and then removing those tuples from a projection. This is a super important tool to have in your tool belt when you are doing recursive pure functional transformations. I'll see you in that video.